Hello students, today we are going to discuss some new points from the 5th lesson heat from subject science part first. What we discussed? We have discussed lot part about this heat and we are going to discuss today that is dew point and the humidity. Before understanding the dew point, we are discussing first humidity. Focus on this diagram just I had drawn on the board. A box contains two layers. First is of water and second is of air. Because 71% of land area of planet Earth is covered by water and remaining part we having to use, that is the land area. Then out of this 70%, 71% of water, we know that if temperature increases, rate of evaporation increases. Evaporation is for all the temperature. But as temperature increases, definitely the rate of evaporation increases and the water starts to convert into vapors. So see here, this is a layer of water, and when there is heavy sun heat, definitely it will absorb the heat. As per the rule of energy transfer, energy will go from or transfer from high region to low region. So definitely this water will get sun heat and it will absorb, and because of increasing heat, liquid will convert into gaseous, that is the vapors. We are generally discussing as a water vapors. So as the water vapors energy is more, definitely become lighter. Because we have discussed in the anomalous behavior, it will expand. So as it is expanding, volume starts to increase and density decreases. But after evaporation, the particles of air is very light one, and so it will float in the air. Suppose these are the particles are floating in the air. So what are these? This part is water, empty part is the air. And this points we are observing on the board, that is what this part is vapors. So where are vapors? Vapors are in now atmosphere, and when the quantity of vapor increases, it will give or it will make that air moist, and such kind of moisture is present in atmosphere. Then this kind of moisture is called as humidity. So see, what is the composition of humidity? The heat from the sun absorbed by the water which is on the surface of earth, and it convert into gaseous state, and water liquid will convert into water vapor. And this presence of water vapors make that atmosphere or air block moist, and this moisture is in the atmosphere is called humidity. So which kind of question we can raise here? Here the definition of humidity. What is the definition of humidity? The presence of water vapor in the air makes it moist, and the moisture in the atmosphere is called humidity. So because of evaporation, we are getting this humidity. So what we are going to discuss about the humidity, let's start now. Air water holding capacity in the air is directly proportional to temperature. Means what? If temperature of air is more, then definitely it can hold more water vapors. If temperature is less, that means capacity of air block is less, so it will not hold more water vapors within that air. So at that time what will happen, that we are discussing or we are going to discuss. But here one thing you should concentrate a lot. When water vapor are present in the air, that air having limitation to hold the water vapors, and this limitation is totally depend on temperature. More the temperature, more air will hold the water vapors, and if temperature is less, water holding capacity is also less. Then suppose at a certain temperature there is a limitation. If there is a more water than the limit, then definitely excess water, because of condensation, it will convert into drops. And if it is less, then it is less than the capacity. Then here, when the air contains maximum possible water vapor, then that air is said to be saturated air. Means what? Now just what we have discussed, water holding capacity is directly proportional to temperature. That means at specific temperature, air block can hold a limited water vapors. So there is a limit on holding the water vapors in the air. That means what? When temperature is 40 degrees Celsius, how much water vapors can be held by that one air? See, for 1 kg air block, that means air is of 1 kg. Then beneath this air, only 49 gram water vapors can be held. That means at a specific temperature of 40 degrees Celsius, only 1 kilogram of air block can hold 49 gram of water vapors. Just what we discussed, this water holding capacity is dependent on temperature. That means now temperature decreases and it is reaching from 40 degrees Celsius to 20 degrees Celsius, then water holding capacity also decreases. The water holding capacity at 40 degrees Celsius was 49 gram, and when temperature decreases from 40 degrees Celsius to 20 degrees Celsius, then this water holding capacity also decreased from 49 gram to 14.7 gram per 1 kg of air block. Then suppose now this is the limit. If this limit is completed, that means temperature of air block of 1 kg is 40 degrees Celsius and water vapors available within that air block is 49 gram, that is of per 1 kg. That means it is a maximum possible water vapors are there. If little extra water vapors are there, definitely they will condense. So if condition is like this one, this air block is considered as a saturated air. Then what is meant by saturated air? When the air contains maximum possible water vapors. At 40 degrees Celsius, 49 gram. At 20 degrees Celsius, 14.7 gram. Then that air is called as saturated air. Then suppose that limit is little less, then what will happen? So it will be considered as a unsaturated air. That means when the air contains less than the possible water vapors, it is said to be unsaturated air block. If it is maximum possible contains, then it is saturated. If less than the maximum possible limit, then it is considered as unsaturated. So air block is saturated or unsaturated. It is also depend on the capacity and what is the content of air present within that one. If capacity is 49 gram and present water vapors also 49 gram for 40 degrees Celsius, so this air block is considered as saturated. Suppose it is 40 gram only, so 9 grams more water vapors it can hold. That means it is less than the limit. So such air block is called as unsaturated air block. As we discussed many times, if the saturation or excess humidity is there than the saturated limit, then definitely that extra water vapors will condense, and after condensation it will convert it to water droplets. Then now our point is dew point. See what is meant by dew point. Come here. With the help of this example, now we are going to discuss. See what is that mean. This is an air block. This is an air block of 1 kg. That means mass of this air is 1 kg. So what is the temperature? Temperature is 40 degrees Celsius. Now temperature is 40 degrees Celsius. For 40 degrees Celsius, capacity is 49 gram. It is a capacity. To make this air block saturated, we need 49 gram water vapors because this block is of 1 kg air and the available water vapors are 14.7 grams. So our task is to make this air saturated. Two means are there. Mean number 1, water vapors presence is less, so increase the water vapors. So you have to add water vapors and make it 49 gram. Then only it will convert as, or it will be considered as a saturated air block. If you do not having this mean, then what to do? Then second option we are having to decrease the temperature, because by decreasing the temperature definitely water holding capacity decreases and it will come to the existing capacity. So what to do? 14.7 gram, this is the capacity or a saturation limit for 20 degrees Celsius. So what to do? Now temperature of that air block should be decreased and it will set at 20 degrees Celsius. So at 20 degrees Celsius, what is that? Limit is 14.7 gram. And now present water vapors is also 14.7 grams. So what happened here? By decreasing the temperature from 40 degrees Celsius to 20 degrees Celsius, after decrease of that much temperature, now this air block is saturated. Because two means were there. The first to increase the water vapors or second decrease the temperature. We have adopted the second mean. By decreasing the temperature of this air block from 40 degrees Celsius to 20 degrees Celsius, we made that air saturated. So such a temperature, without increasing or decreasing the water vapors, by changing the temperature, this temperature is considered as a dew point. Got the point? So what is dew point? Suppose unsaturated air at certain temperature is taken. 40 degrees Celsius, certain temperature. 49 gram was the capacity, but now availability is 14.7 gram. So definitely it is unsaturated air block. Is taken and the temperature is decreased 40 degrees Celsius to 20 degrees Celsius. So a temperature at which the air becomes saturated, this air block is saturated at 20 degrees Celsius. With vapors, this temperature is called the dew point. So what is dew point? So a unsaturated air block at a certain temperature is taken and its temperature is decreased. Then the temperature at which the air block becomes saturated with the vapor, so that temperature is called as a dew point. After discussing this part, we are moving to the next part, that is absolute humidity. See, what is absolute humidity? It is a physical quantity to measure the water vapors or vapor content. So, how much water vapor are there in a specific air block? That is nothing but what? Absolute humidity. So, what is the definition? The mass of vapor present in a unit volume of air is called absolute humidity. So, see here. What is meant by unit volume of air? See, we have to prepare one box, the empty box. How the box should be? The length of box is 1 meter, the breadth of box is 1 meter and height of box also 1 meter. So generally this box is considered as a 1 by 1 by 1. 1 by 1 meter means what? Length 1 meter, breadth 1 meter, height also 1 meter. So if by using the formula of volume, if you find the volume of this block or a box, empty box, that is volume is equal to length into breadth into height, that is 1 meter into 1 meter into 1 meter, that is 1 cubic meter. And the air present within this box, that means the volume of this air is also now 1 cubic meter. And when the air block is 1 cubic meter, that air block is considered as a unit means 1 cubic meter volume of air. Then within this volume, that means within this air block, how much water vapors are there? What is the mass of water vapors? That is called as absolute humidity. Means what? See here, unit is kilogram per cubic meter. That means in 1 cubic meter of air, how much kilogram water vapors are there? That is called as absolute humidity. Means what? If within this box, if 3 kilogram water vapors are there. So what is absolute humidity of this air block? 3 kilogram per meter cube or cubic meter. Suppose it is only 1.2 kilogram, then the absolute humidity of this air is 1.2 kilogram per cubic meter. That means within this volume we having only 1.2 kilogram of air. So this is called as absolute humidity. So what is the absolute humidity? The mass of vapors. The mass of vapors present in unit volume of air means 1 by 1 meter of the air block is called as absolute humidity.